Hello, students. Good morning. I wanted to give you guys a chance I wanted to go over this quiz with you all so that you could see what mistakes that you made. It gives me a chance to try and explain it a little bit better or in a little more detail than I could maybe in a Zoom meeting. So what I'm going to try and do is I'm going to go over this quiz with you all. Then, if you would like to maybe improve your grade and resubmit, you'll have that ability. My hope is that you'll understand a little bit better. I know that it's been difficult. Something I realized when I was talking to my wife last night, who's also a teacher, is that one of the things that makes this online learning really difficult, and it's just another challenge that we have to try and overcome, is that a lot of this material is meant to build. It's meant to be like, all right, I teach you about this, and then 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 it increases learning. But the issue is, because I'm only able to talk to you guys for about 30 minutes a day, everything's slowed down, okay? And so I don't have that momentum. So I'm going to try and go over this, try and give you guys some help. And one thing that I've encouraged multiple times before, is that if you don't understand something, please ask me in the Zoom. There are multiple times when I try and say, okay, are you guys good? Do you have any questions? That's your time to type in the chat and say, no, I don't really get that. Can you go over blah again? So make sure you're doing that. Anyway, let's get to it. So it says, in terms of electric pressure, describe a charged capacitor. Not a problem. So this is something that we've talked about before. I know it's been a while, but it is something we talked about before about how capacitors store charge. So in terms of electric pressure, so a charged capacitor is one that is full of charges provided by a specific number of batteries. I could also say this by amount of voltage. Okay. All right, can I make it so it doesn't do that? There we go. Yeah. Okay, so that's really what it is. A charged capacitor is one that is full of charges provided by a specific number of batteries, amount of voltage, I think is what I tried to say. There we go. And the top plate, it's usually the top, but it doesn't have to be, is filled with positive charge, and the bottom plate has an absence of positive charge. Now, I'm obviously going by the conventional method of charge. This is the Ben Franklin way of saying, oh, charge goes from positive to negative. We know that's wrong, but that is what we talk about when we're doing circuits. Okay, so there we go, charge capacitor. This excess, or how about this, abundance of positive charge pushed together in the top plate creates pressure. As the charges repel one another and want to get away, but are unable due to the constant pushing from the battery, okay? And so that's really what happens. You get all these positive charges that get on the top plate of a capacitor. They want to get away from one another. Like charges repel, but because that battery is pushing them on, they're not able to get away. Okay. Next one, I'm going to make this font just slightly bigger. It's kind of small. We'll just keep going. Next one, it says, in terms of electric pressure, explain why a capacitor stops charging. Okay, so as previously mentioned, the capacitor becomes full of positive charges on the top plate. And at a certain point, as the battery continues to push charges through, or how about this, push charges onto the top plate, the charges already on the top plate repel additional charge. So basically what you have to think of is at a certain point, there's so much charge, there's so much pressure that gets built up on the top plate that the battery can't push any additional on there. The battery's not strong enough, okay? And so that's really what we're talking about here. And by the way, as I'm giving you guys these answers, always try and put it in your own words. I'm explaining it the way that I would, and notice I try and be very detailed, but I'm looking for something like that. For this question, assume you start with a circuit containing a battery, 2 long bulbs, and a charged capacitor. Now that's important, because if it's already charged, that means some stuff is going to already occur. Okay, so it's already a charged capacitor. And why isn't this working? Go figure. There we go. Charged capacitor. There we go. And the reason that's important is because if it's already charged, that means that we're going to need to keep that in mind for the next part. Predict what you would observe when an additional identical battery is added to the circuit. And then we see that in 3B. So what do I predict will happen? Well, you've got to think about it this way. Like I said, one battery may not be strong enough to put any additional charge on there. So like if we look at this top plate, maybe it's already loaded with charge. Okay, it's already got a bunch of positive charge. The bottom plate already has an absence of that charge. But the thing is, if you have an additional battery, it's a little bit stronger. It can force more positive charges on that top plate because now you got not just one battery, but 2 batteries pushing charges on there. So it's a lot stronger. So let's type something along those lines down here. Okay, predict what will happen. The long bulbs will light a second time as additional charges and therefore flow move onto and off of the capacitor. And what I mean by that is, like, if you have that additional battery, it's going to push charges onto the top plate, and extra charges are going to get repelled off the bottom plate, and it's more pressure, okay, more pressure on that top plate. So there's my prediction. Light bulbs are going to light up as a second time, and then how about this? As the capacitor becomes full with 2 battery limit, how about that? Bulbs will go out again. There we go. That's what I'm looking for there. There we go. That looks great. Explain your reasoning. Well, one battery only has a certain amount of strength. Golly. So let's say that's, 1.5 volts, which is the voltage you get out of a AA, a AAA, a quadruple A, DC, whatever. So one battery only has a certain amount of strength and is only able to push a certain amount of charge onto a certain capacitor. Let's put it that way. An additional battery can push additional charges. Golly. Guys, I can spell, but apparently I can't type this morning. It's the pressure because I know I'm being recorded. So an additional battery can push additional charges due to the increased pressure, the increased strength, etc. So one way that I've explained it to you guys in the past is I talked about, imagine 2 people blowing through straws to try and fill what I called an air capacitor. And if you don't believe me, you can look back at your notes on capacitors. One person is going to be able to push a certain amount of air in there. But 2 people, both blowing at the same time, can put even more. They can compress even more air into that charger, that capacitor. And so the same thing is true of charges. Use color coding, oh boy, to determine the order of brightness of the bulbs as seen in the circuit below. Rank the 3 bulbs, A, B, and C, from brightest to dimmest. And it says all 7 bulbs are identical. So one thing that I've talked about before, and I would like to remind you all about again as soon as my tablet decides to wake back up. It closed everything out. Thanks tablet. Is remember we have these different colors. So you're going to have red, orange, yellow, green, and finally you're going to have blue. And what I tried to tell you guys is that if you're going from like one to another, like 1 to 1, like a jump of 1, that's going to be not very bright, okay? But if you're going from red to yellow, maybe you're doing a jump of 2 color differences, a double pressure difference, then it's going to be a little bit brighter. Maybe it looks like that. If you're going from red to green, maybe it's going to be just a little bit brighter, okay? And then if you're going from red all the way to blue, well, now that is about as bright as they come. And it's because the bigger your pressure difference, the brighter that bulb is going to be. The bigger the difference in pressure, I don't like to say the word faster, but basically the increased rate of charge that's going to get pushed through that bulb very, very quickly, okay? It's higher pressure, it's pushing charges through more quickly or at a higher rate. And so we'll see that as brighter. So the reason that's important is that as I color code these, okay, and always start with the positive end of the battery, start with red, go everywhere that you can with red without lifting your pencil, okay. So we'll go over here, boom, just like that. So there's all my red. Next one I always do is the blue. Start with the negative end of the battery and go everywhere that I can with blue, like so. Same thing over here. Yep. And then I stop. And these are actually circuits that we've color-coded before. If you don't believe me, you can look back at the worksheets that we did. That's going to be yellow in between there. It wouldn't make sense to say orange between B and whatever that other bulb is up there. It wouldn't make sense to do orange because then I'd have a smaller pressure jump from here to here and a larger pressure jump from there to there. It needs to be yellow so that it's even. We would expect bulbs, I don't know, I'll make this bulb Q. We would expect bulbs Q and B to have the same brightness because of the way that they're oriented. And so that's what we'll represent. Now over here on the other circuit, I can also put yellow in the middle. I know it's going to be yellow somewhere over there, but here is going to be orange on that little leg, and here it's going to be green on that little leg. Because the thing is, every time you go across a bulb, a little bit of pressure gets relieved. So if you're going from red, high pressure, go across bulb C, now we're down to orange. Still quite a bit of pressure, still quite a bit of energy that those charges have to give, but every time you go across a bulb, it gets less and less and less and less, okay? And now Mr. Bass is chatting with me. He said, good morning. Good morning. Okay. So now that we've done that, now that we have our kind of brightness scale, the biggest jump that we see is red to blue, and it's right there on bulb A. So I'm going to go ahead and make bulb A super, super bright. Now I know what you're going to say. Wait, it didn't say to diagram them. No, it didn't, but it is going to help me, okay? Now in B, I see that I'm going blue to yellow. So that's a pressure jump of 2. So maybe B is just going to be a brightness of 6. Maybe that one's only 6. Now over here on bulb C, that is a very small pressure difference. We're going from red to orange. Not a huge jump. And so because it's not a very big jump, it's only going to have 4. So my brightest is going to be A, my dimmest is going to be C, and B is somewhere in the middle. And it's because of the pressure differences. Let's take a look at our next picture, okay, our next image. Color code, you got it. I'm going to start with red. I'm going to go a little bit faster this time. I go everywhere that it makes contact. I'm going to do the same thing with blue. And I go until I hit something like a bulb. And there we go. So there's my red, there's my blue. Which bulb is going to light? Both of them. And I'll represent that by just showing something like that. Okay, there we go. Next one. I hope that makes sense to you guys. There were no obstructions. Red to blue is a large pressure difference. Blue goes everywhere from the negative end of the battery. Red goes everywhere from the positive end of the battery. So those are both going to light up. Now let's look at number 6. Maybe one of these doesn't light. No, looks like they're all going to light up. Let me show you why. Start with red. I go everywhere that I can without lifting my pencil. Wow, that was kind of sloppy. Let me do better than that. I can do better than that. Okay. So there's the red. Now let's look at the blue. And so the thing is, we're still going red to blue, red to blue. Now there's probably a cleaner way to draw that circuit so that it's not so messy. But it's fine. They're doing that to try and confuse you. So which ones are going to light? All of them. Now, these are round bulbs. They're not as bright as long bulbs. And again, I didn't ask you to do that in this problem. But if I were comparing round to long, I would want these to be a little bit dimmer. So compared to problem number 5, I'm just going to make these all 6 instead of 8, just because they are having a red to blue pressure difference. That is a huge pressure difference. But I don't know, just to make sure it correlates to number 5, I'll make these all 6 instead of 8. Number 7, all bulbs and batteries are identical. That's great. Color code all 3. You got it. I'm going to start with red and go everywhere that red can go in each of these circuits. Then I'm going to switch over to blue. I'm going to go everywhere that blue can go in each of these circuits. I'm going to go ahead and go out on a limb and say bulb B is probably going to be brightest. I'm going to do the same thing with my other colors. And I don't know, just because I have to, if I'm looking in that first circuit right there, the reason I'm going to do orange and green is because yellow doesn't really work there. It doesn't fit, but I can do that. Okay, I can do that, and it works. It's close enough. Now, the reason that's a little weird is because if we look back, an orange to green jump is a jump of 2, and that'd be kind of wrong. We would expect all bulbs in the first circuit to be the same brightness. So I don't know, if you wanted it to be kind of funny, you could make this kind of an orangey yellow, and maybe this is kind of a greenish yellow, but I'm just trying to show the pressure difference is going to be the same, okay, across all 3 bulbs in that first circuit. Now, in the second circuit, it's red to blue. That's a huge jump. Last circuit over here, circuit we've already seen earlier today, up here in the last problem. It's basically the same thing. So I'm just going to color code it the same way. Looks kind of like that. So first off, okay, color code, check. We have done that. Next thing, it says rank them in order of brightness from brightest to dimmest. All right, guys, B is going to be brightest. It just is. Because B goes from red to blue. That is a huge pressure difference. The bigger the pressure difference, the brighter the bulb's going to be, because more charges are getting pushed through, okay, in general. Higher flow rate. Another way we could look at this, and I know that's not what the question's asking, but if all these bulbs are identical, this is what we'd expect to see in terms of flow. Okay, something like that. Same flow rate all the way through, okay? But then if we look in the next circuit, maybe this one is, I don't know, 6. 6 is fine. And then it would be 6 over here in this branch. But look, when you go down each branch, it's going to go down to 3 and 3. Okay, and hopefully it'll load. There we go, here in a second. So still pretty big pressure difference, higher amount of flow. And then in my last circuit, that's going to be almost no flow, just because that's a lot of resistance. The higher your resistance, the lower your flow rate. Okay, and we'll see that here in a second if my notebook stops acting stupid. Maybe. There we go. And again, you don't have to do that. I'm just showing you. If we look just at color coding, though, I know A is going to be the next brightest. Okay. And then my last one, it's going to be a very small jump, is just going to be C. So however you want to think about it, if you look at it just in terms of coloring, that's one way to look at it. But another way to think about it is that, look, as you add additional bulbs in series, okay, this first circuit over here, this last circuit over here are both series circuits. As you add more and more bulbs that way, the dimmer and the dimmer the bulbs are going to get, because the resistance increases, the battery stays the same, and the current decreases. That pressure difference gets shared across every bulb that's in series. So as you add more and more bulbs, the individual pressure difference gets smaller and smaller and smaller, to the point where if we had a 4th circuit, which we don't, but if we had a 4th circuit that maybe had, I don't know, Maybe it's got a bunch of bulbs. Maybe it looks something like that. We're going to have a lot more colors. Yes, we'd still have red, we'd still have our blue, but now maybe our yellow's over here, okay? Then maybe we have our, oops, not green, that's going to be orange. Pardon me. Here's my orange. Maybe down here's my green, but then maybe I have to have a light green that goes there to there. And then maybe between orange and yellow, I got to have an even lighter color. Maybe it's this one. Let's use this one. Here we go. There we go. Beautiful. But it'd have to look something like that. And now my brightness is very, very little because the pressure difference is getting shared so much. Oh boy, an announcement.
Mr. McGill, please come to the front of the school. You have a student waiting. Mr. McGill, please come to the
Okay,
front of the school.
so guys, that's enough for right now. If you're still having trouble with color coding, I highly, highly recommend that you, first of all, go back and look at the reading. There is a reading that we did on this. Unit 1, Worksheet 5, I think is what it was called. I'll show you. Here we go. That explains color coding a little bit. If you're having trouble with diagramming, well, we've talked about diagramming quite a while ago. Don't let me find it. Is it this one? Yeah. So back here on Unit 1, Reading 7 is where we started talking about that. But the thing is, all this stuff builds on one another. What you understand in Worksheet 5 builds on what you do in Worksheet 6 and 7. What you do in Worksheet 6 and 7 builds on what you talked about in Worksheet 8. And by now, I've tried to explain it all the best that I can. If you're still having issues, I beg you to contact me via email or stay at the end of a Zoom. At the end of a Zoom, I always say, if you have questions, please stay. And not a lot of you have been taking me up on that. So I recommend that you do. So do that quiz. If you have issues, please let me know. I want to help you, and I hope this was somewhat helpful.